EngineBEERing, EngineBEERing with Timothy Freeburn. Yeah, that's probably good enough, isn't it? Hello everyone, welcome to EngineBEERing with Timothy Freeburn. This week I'm going to make sure I open a beer straight away. It's going to be the first thing that I do, just otherwise I might not drink one at all, which would be terrible, totally against this this show. So this week I've got a Doom bar. So last week I had Landlord, and I used to really like having a Landlord and Timothy Taylor's Landlord, and then having a Doom bar, or sometimes vice versa. But they just sort of seem to be very, very different flavours, and you sort of get honey notes out of some and not out of others and things like that. So here we go, let's pour this out. If you don't like this beer, what you should do is send me some suggestions. So, there we go. Look at that. Right, let's have a go at that. Very fizzy. Actually, I'm really not getting much body out of this. This is much better on tap in a pub than it is out of a bottle, and that is quite common with real ales. It's not really real. In a bottle, there's no sediment in the bottom of that. So anyhow, so we'll put that to the side, and yeah, let's talk about what we're going to talk about this week, and that's going to be first of all brewing. Let's talk about water treatments. Why do we treat water? Well, that's actually a really good question. What we want to do is, first of all, we want a beer that tastes good. You don't want your beer to taste of all sorts of things like chlorine and things like that, with the preservatives and things, or the things that remove bacteria, etc., out of water. So we're not worrying about transporting this water through pipes to the other side of the country or something like that. But when you get water out of the tap, that's exactly what they have to worry about. They need to worry about, they're not going to give you some sort of illness or something because of something that got into the water. So there's lots of chemicals and things to make sure that water is safe to drink. And when we're brewing, we can sort of strip back those chemicals and sort of offset them a bit by adding other things to sort of neutralize and hopefully not ruin flavors. Another reason is for efficiency. It's probably not so relevant on a 25 litre, 23 litre batch I brew with, but it's not really that relevant. But if, for example, you were doing a 10,000 litre batch or something like that in a brewery, you very much care how efficient you are, and that is, how much malt you're actually turning into alcohol. And the third reason, there are many reasons, but the third I can think of, is that we want the ability to replicate a beer. So if, for example, we make a beer here in Cambridge, and we want to go down to our friends in Canterbury and sort of brew there with them and make the same beer, and it should taste the same, then the differences locally between Cambridge water and Canterbury water will very much give a very different taste to that beer. And so the idea here is that we neutralize, or we take the water to a known point, so that if we brew here or we brew there, the results are very much the same. So the first step in water treatment is to go to someone like Murphy & Sons, and you send them a vial. You just take a little bit of water out of the tap and screw it up and send it to them in the post. And what they do is send you back the documents which sort of tell you a little bit about your water, mainly sort of how much salts there are in it, how hard your water is, that sort of thing. And what they do is give you some ideas for improvement to brew the beer you want. And that's fairly important to know that there isn't a right profile for water. There isn't, this is exactly what you're going for. What it's actually about is different styles of beer actually require different water profiles. So if, for example, you're trying to replicate the same sort of beer, a Pilsner in Pilsen in the Czech Republic, you want a water that tastes very much like that water from that region. And that's very different to, for example, if you want a London stout, you want to have a water that is very similar to that region. So, for example, a London stout is very heavy water, whereas the Pilsner water is very light. So, what these profiles actually do give you is, if you're making a stout, this is the sort of treatments that you want to add. If you're making a Pilsner, this is the treatments. If you're making and that's a very useful guide to have. So let's talk about some of the things that I use, and it's probably the same sort of thing that most people use. But okay, first of all, AMS. That is a calcium reducing solution. That's about it, yeah. It's an acid. We are adding acid to water to, well, we'll get to that in a second. But lactol, which is lactic acid, what that does, what the acids do is combat, so for example, the chalk in your water. If the chalk is actually reducing your pH a lot, then you want to add some acid and offset that. So that's our acids. There are also salts that you add to the water. So for example, we've got this one, which is, I don't know if you can see that, DWB. That is a collection of different salts, and we're just adding those to increase the minerals. And the amounts that we add all of these things are to those profiles. So for example, if we do want a stout, we might be adding a lot. If we want a Pilsner, we might not be adding a lot of that. Another thing is calcium chloride. It's also a salt. It lowers the pH, preserves mash enzymes, that sort of thing. And finally, what I have here is some calcium sulfate or gypsum. So what this does is, again, gets pH correct. It improves the flocculation in the fermentation vessel. Yeah, an interesting note about this one is that as the temperature increases, it does the opposite of what a normal salt would do. It loses its solubility. A normal salt, you increase the temperature and it dissolves into the water. With this, the hotter it is, the less it will dissolve. So that one you need to add straight into the mash tun, not into your hot liquor tank before you transfer across to your mash tun, do your sparge, etc. So that's it about water treatments. That's beer. Let's now talk, after I have another sip, this is very important. There we go. Let's talk a little bit about engineering. So what I wanted to do today was to tell you the difference between, for example, a drill bit in a drill chuck and an end mill. And what this is actually, we have a part that we put into our mill, something like that, or you might have a drill press or something like that. But okay, if you've got a drill bit in a drill chuck, then what you are doing is you're pushing straight down and all of the force is transferred that way. There is no force transferred along the side of this when you're drilling. So a drill chuck is designed only to accommodate forces in that direction. Where an end mill is sat inside a collet, and what we're actually doing with this is we push that up hard against a part, and that collet is designed to take that force in that direction against it. So if you tried to do that with the drill chuck, you potentially break the drill chuck, or you damage it, or it sort of starts to wobble about, etc. Whereas the end mill certainly won't do that. So that's a bit of information about that. So today is Take Your Dog to Work Day. And we didn't have a dog here today. We normally do have a dog, but it was a bit hot today, so Paula left her dog at home. I don't have a dog, I have a cat. But anyway, that's Happy Take Your Dog to Work Day. And tomorrow is InWed 18, Women in Engineering. So go and have a look at all the hashtags for that. Support women in engineering, fantastic. So please like, share, subscribe, comment, tell me what beers to drink, and have a beer yourself. Maybe in the opposite order. You have a beer and then you comment, and then we get all sorts of entertaining and amusing comments at the bottom. That sounds good to me. So anyway, thank you very much for watching, and we'll see you next week. Cheers.